we're moving on to chapter 3, section 2. We're not going to finish this. We're going to do it in 2 days. Again, I need you guys to pay attention on what this is. I'm going to explain it and just follow along. So we are learning end behavior, okay, meaning our graphs are going to look different than what they've been looking like from before. So I'm just going to give you an example what end behavior is, where it is on the graph, what does it mean. So giving you an example, let's just say we have x squared. What would that graph look like? It'll be a u, okay? This would be a u, okay? My quadratic function, if I'm graphing it, this is what it would look like. Now, what end behavior is where my arrows are going, okay? In what direction? Where are they facing? Is my left side going up? Is my right side going down? What is going on? So end behavior helps us to determine what my graph is going to look like in the end. Okay, so when we're given pieces of information, that's what we're going to take off to find what we have. There is a chart for this, but I'm going to kind of do my best and explain everything. So if you, this is a lot to remember. If you don't remember the chart, as long as you remember the rules. All right, so I have leading coefficient test. Okay, this is my leading coefficient test. We're going to be using specific parts of my leading coefficient, okay? So if you want to look up more examples, just look up leading coefficient test and I'll show you other examples. So this has to do with my term, my first term in standard form, okay? So write it in standard form, highest exponents first, all the way down, okay? And this is going to help us determine what my end behavior is going to look like. So if I have an odd degree, okay, so giving you an example for odd degree, if I have number, just writing number sign because it could just be any number. If I have, let me do it in purple so we can kind of see better. If I have any number and then I have x to the power of 3. My degree is odd, okay? That's where I'm getting that odd degree from. I'm looking at that first term, okay? My highest exponent is odd, and what does that mean? My end behavior is going to opposite. It's going to be opposite behavior. Think of O for odd, O opposite, meaning it's going to go in different directions. Like my arrow's going to either, one is going to go up, one is going to go down, and vice versa. So now how do I determine which one falls or which one rises depending on the direction? Now that has to deal with my leading coefficient. Okay, leading coefficient. Oof, shouldn't have an equal sign here. My leading coefficient, okay? So now I'm gonna look at that number. Doesn't matter if my number's odd or even. I'm going to determine, now, is that number positive or is it negative? And if it's positive, it falls to the left and rises to the right. And again, if my leading coefficient is negative, it rises to the left and falls to the right. Okay, so this has to deal with an odd degree. So for this question, again, I am looking at my degree, and this is odd. They're opposites. Now let's say I have my number. I have my number, and my degree is even. Okay, if my degree is even, it's going to have the same behavior. Okay, so looking at the same behavior, if it's a positive number, it points up. If it's a negative number, it points down. So showing you what points up means, meaning my graph is going to go up. Both of my arrows are going to be going up. And if it's negative, both of my arrows are going to be pointing down. Okay, so again, a lot of information here. there is a chart. I'm not saying you have to memorize the chart, but the chart will help a lot of you. Sometimes you guys like to just, as soon as you get your test, write it down, which is fine. I'm going to go ahead and draw the chart right down here in the corner so you could see it. And again, like I said, if you memorize the chart, that's fine. It does not have to be that big. I'm going to make it smaller. So I have my degree. Remember, my degrees could either be odd or even. Okay, that's what's written in red. I have degrees that are either odd or even. So if you're looking at the chart, my degrees are either odd or even. And then my leading coefficients are either positive or negative. This one, I didn't write it here, but this one is also looking at the leading coefficient. Leading coefficient. So now on this side, this is my leading coefficient. And like we said, we could either be positive or negative. So what is it going to look like in this chart? If I have an odd degree and it's positive, it's going to be arrows, one going down, one going up. And if it's an odd degree and it's negative, it's going to go up and then down. And then now when I have an even degree, okay, remember odd, opposite, even is the same. So if it's positive, they're both going up, and it's negative, they're both going down. Okay, so this is a chart that you could memorize that kind of explains everything. But most important thing is you have to remember these are your degrees, and these are your leading coefficients. Okay, do not forget this. This is super important to help you find that end behavior when you're given, when you're asked to graph something. So just to say it again so we all hear it, this has to do with that first term. Okay, keep in mind, in your function, you are writing it in standard form. Your highest degree must go first, and then you're looking at the degree, if it's even or odd, and the positive or negative leading coefficient. That's going to help you determine where my end behavior is. Remember, the end behavior is the arrows. Where is my arrow pointing after I graph? Okay, this is again just the arrows, not what's in between the arrows. All right, looking at this one, zero multiplicity. Zeros we have done already. I don't think I really need to explain it. All you're doing is finding your zeros in the function. So if you can factor, make sure you factor and set everything equal to 0. All you're doing is setting it equal to 0, and again, you're just finding those zeros. We did that in 3.4 and previous lessons. So that's just something that we should already know how to do. Now, multiplicity, we kind of touched on it last class with 3.4 with one of the examples. Okay, what is multiplicity? I'm just going to give you an example first, and then we're going to kind of look at what it means. So giving you an example of multiplicity, again, we kind of touched on this last class when we had 2 of the same zeros. So I'm going to give you an example. Let's just say we have the function f of x equals x minus 1 squared and x plus 2. Okay, first thing I have to do is I'm going to try and solve for my zeros. Trying to find what they are, so setting it equal to 0. How am I solving? I'm going to have x plus 2 equals 0. That's going to give me x equals negative 2. That's one of my answers. And then I have x minus 1 squared equals 0. Another way to write this, we should know this, is x minus 1 times x minus 1. Okay, same thing, x minus 1 equals 0, x minus 1 equals 0, and I'm going to get x equals positive 1 and x equals positive 1. So if I'm looking at it, I have a total of 3. I have a total of 3 answers. What is that telling me about my degree? I'm going to have an odd degree. Okay, what do I mean by odd degree? Meaning if I was writing out my function, it would start with a number x to the power of 3. And again, what is that 3 telling me? The 3 is telling me I have 3 answers. And it's also telling me that I have an odd degree polynomial. Okay, so if I were to graph something like this, I know the direction my arrows are going in. I have a positive number and an odd degree. Okay, I have odd and positive. So again, graphing it, just giving you an example. This is just going to be a quick little rough sketch. It's not going to be perfect. I'm going to have a dot on, what was my first one? -2. And a dot on 1. Now, because I have an odd degree, odd is telling me my arrows are in the opposite direction. And because my number is positive, it's going down and it's going up. Okay, this is where my end behaviors come into play. Okay, this is telling me that this is what my end behaviors are going to look like. Now, do I know what the middle is going to look like? No, not yet. Okay, now that's where we get our multiplicity. What is my inside going to look like? That is my multiplicity. So going back to this question, because I have -2 once, this one has a multiplicity of 1. And now I have x equals 1 and x equals 1 twice. So what do you think the multiplicity of this one is?
1.
Multiplicity of 2. Because I have 2 of the same thing. Okay, now let's figure out what multiplicity means. Okay, this is where we have to know what multiplicity means. If an even amount of times, if it occurs an even amount of times, so I'm going to highlight that. If it occurs an even amount of times, then the graph is going to hit the x-axis and turn. It's going to bounce on the x-axis. I'm going to call it a bounce. Okay, if it occurs an odd amount of times, it's just going to cross through. So this is just cross. Okay, what do I mean by cross and bounce? I'm going to go ahead and just zoom in on the graph again. If something crosses, it's just going to cross my x-axis this way. Okay, where does it cross? We don't know yet. So just giving you those examples. This is crossing. This is crossing. It just crosses my x-axis. Now, if something were to bounce, what would that look like? It's going to bounce on my x-axis. Okay, so it's going to bounce on that axis. Okay. So let's go ahead and look at it. This one has an even and an odd. So looking at the first one, a multiplicity of 1. Is that an even or an odd number? It's an odd number. So I know it's going to cross at -2. This is -2. It's going to cross somewhere at -2. So just showing you, I'm going to do it in green. It's just going to cross at -2. Okay, I'm crossing it. I'm just drawing a straight line through -2 according to my end behavior.
Straight line or like?
Straight line. It's just going to cross. It's not going anywhere else.
It's not gonna follow the...
Now I have a multiplicity of 2. Is that an even or an odd number? That's an even number, and it's going to bounce. What do I mean by bounce? I'm going to show you. That means according to my end behavior, it's going to bounce off of that 1. Then I have to connect these. Where does it connect? Don't really worry about it. You're going to have to plug in, which we're not going to do. All you have to do is connect those. These are the only 2 dots, so they have to be connected somewhere. And because it's bouncing at a +1, you just have to end up connecting it in the end. Okay, so you have to know the difference between if it's an even or an odd multiplicity. And we're going to get into the example, and it'll make a lot more sense once you're starting to use it. All right, there are strategies to this. There are steps. We're going to kind of do these steps in an order that makes sense, that works out. We are not going to be plotting additional points, meaning plug it in. You don't have to do that. You really only have to focus on these three. So find the end behavior, determine the end behavior, find the zeros in multiplicity, and find your y-intercept. So that's what we're doing. Let's go ahead and go to the example, okay? First thing I would do is find my zeros. We did that in 3.4. That is, to me, going to be the easiest thing. And then it kind of gives me the answers for everything else. So I'm going to go ahead and find my zeros. So I'm going to put number 1 right here. That's what I'm going to do first. And I'm going to go ahead and do it up top. How do I find my zeros? Okay, remember, finding your zeros for a function, if a factor is not given, you need to take the factors of the last number, which is 6, and factors of the first coefficient, my leading coefficient, which is 1. And writing out all those factors, they have to be positive and negative. So I'm going to have positive, negative, 1, 2, 3, and 6. Why don't I put it over 1? Because that's just going to give me a whole number. All right, now I'm going to go ahead and use synthetic division. I need to find a factor. I'm going to go ahead and do 1 first. And then taking all my coefficients, I'm going to have 1, negative 2, negative 5, and a 6. We should all know our synthetic division. Bring down your 1. 1 times 1 is 1. Okay, negative 2 plus 1 is negative 1. Negative 1 times positive 1 is negative 1. Adding these two, I'm going to get negative 6. Negative 6 times 1 is negative 6. And I have a remainder of 0. So is 1 one of my zeros? Yes, so I'm going to write x equals 1. Just circle that. That's one of my answers. And now I need to determine, can I factor this? So because I started with x to the power of 3, you have to go 1 degree less. I'm going to have x to the power of 2 minus x plus 6 equals 0. Can I factor this? Or you're right, minus 6. Minus 6 equals 0. Can I factor this? What number multiplies to give me negative 6 and adds to give me a positive 1? I'm going to have x minus 3 and x plus 2. Set them both equal to 0, and all you have to do is solve for x. X minus 3 equals 0. I'm going to get x equals positive 3. And x plus 2 equals 0. I'm going to get x equals negative 2. Now let me just double check. Am I supposed to get 3 answers? Yes, because of my degree. Okay, my highest degree is 3. So that's the first thing. We should know how to do that again. Yes, that should be the easiest. Well, not easiest, but that should be an easy part. I have x equals 1, x equals 3, x equals negative 2. Now the next step, you're going to take your zeros and plot them on the graph. So I have 1, I have 3, and I have negative 2. Okay, all I did was find the zeros, plot them on the graph. Again, we're going to do them in steps. Okay, next part. I'm going to go ahead and find my multiplicities. Okay, this is my next part, my multiplicities. So looking at this, what are the multiplicities for each 0? 1. So I'm just going to write, none of them are repeating, right? None of them are repeating. So I'm going to write all. They have a multiplicity of 1. So what is that telling me? Is that an odd number or an even number? Odd. So if it's odd, is it going to bounce or is it going to cross? Good. So that's behavior at x. That is step 3. Okay? So because it's an odd multiplicity, it's going to cross. So what does that mean, crossing? I'm going to look at my graph, and all that means is I'm going to cross at my dots. Okay, so draw little lines on those dots. Again, it's not bouncing, it's just crossing. So it's going to go through your zeros. All right, now I'm going to go ahead and look at end behavior. Okay, that's what I'm going to do. Look at my end behavior. So this is 4. And remember, my end behavior has to do with that first term. Okay, my degree, is it odd or even? So my degree is odd. And is my number positive or negative? It's positive. I have an odd degree and a positive leading coefficient. So because it's odd, are they in opposite directions or the same directions? They're opposite directions. Now I need to determine, am I going down first or up first? I'm going to go down first and up. That's all you really have to do. You could just draw it out. You don't have to write it out. So my end behavior, how is that going to help me with my graph? That means this is going down and my last dot is going up. Okay, so we could kind of see it coming together. Now I have one more thing I have to find, which is my y-intercept. Okay, that's the last thing I have to find. Now my y-intercept, we have to remember how to find this. So for my y-intercept, that means I have to set x equal to 0. Looking at the function, we should already know what the answer would be. Does anybody know what my y-intercept would be?
6.
It's just going to be 0, 6. But if you did not know it was going to be 0, 6, all you have to do is plug in 0 for x. 0 cubed
You have to write
minus 2. I'm just showing you guys, if you didn't know, all you're doing is plugging in 0. And all that's left would be your c in this case, or just the last number, which is 6, which is 0, 6. Now, I have to graph this as well. Okay, you have to graph your y-intercept. And it would be right here on this 6 dot. Okay, so now what is my graph going to look like? I'm almost done. Now I can go ahead and start connecting things. It has to go through the y-intercept, so I'm going to go ahead and continue this green line through the y-intercept, through the next dot, going all the way to the end. Now, how low do I know this is going to go? If you were to plug in something, we're not forcing you guys to plug in anything. This is good enough. And this is what your graph is going to look like in the end. All right, example number 3 again, finding the steps, solving however you want. I mean, if you want to do the end behavior first, for all means, let's go ahead and we could do that one first. It's still going to work out the same. The only thing is, the reason why I do the zeros first is so you can get those points. Because if you know what the end behavior is, that's great, but you can't really graph them until you have the zeros. So let's just really quick see our end behavior. What would my end behavior be?
It would be odd and positive.
Good, it would be odd. Remember, odd has to do with the degree. Okay, it has to do with that exponent. And then it's positive, and that has to do with my leading coefficient. Okay, so just writing it above it where I'm getting that odd and positive from. So it's going to go opposite direction, and because it's positive, I'm going to go down first and then up in the end. All right, let's go ahead and find our zeros. Finding our zeros, finding my factors of my last and factors of my first. So this one's going to take a while. I'm not expecting you guys to write all of this. I'm going to write it, but you can only, you don't have to write all of these. Okay, so factors of my first, factors of 12, I'm going to have 1. I'm going to have 2. I'm going to have 3, 4, 6, and 12, and then factors of 2, 1, and 2. Keep in mind they're all positive, negative. Okay, what do I mean you don't have to write all of these? It's not going to be the first one. I'm going to tell you that right now. So I'm going to show you all the work for synthetic division, but it's going to be quite a lot of them, so you don't have to show all the work. You could go back and erase it. So this is going to take a while. because I have to do all of them. Let me try and get a darker green so we can see this a little better. Okay, hopefully you could see this one a little better. Okay, so I'm going to take those coefficients. I have 2, -1, -25, -12. Okay, yes, on your test and quiz, you have to try all of them, even if it's 6, okay, in order for you to find those factors. So bring that 2 down, okay, 2 times 1 is 2, I'm going to end up with 1. 1 times 1 is 1, I'm going to get -24. And clearly this is not going to be one of my factors, so I'm just going to go ahead and cross it out. Okay, going to the next one, I'm going to go ahead and try -1. So I have 2, -1, -25, -12. Someone last class asked, can I just cancel it out if the positive doesn't work? And the answer is no. You have to test it because when you're adding and subtracting the numbers, they're going to give you different values. So I'm bringing down my 2. I'm going to end up with -2. I'm going to get -3, +3. This is going to give me -22. And clearly this one's not going to work either. Okay, my 1s are not going to work. Let me go ahead and move on to my 2s. 2, -1, -25, -12. Synthetic division. Bring my 2 down. 2 times 2 is going to give me a 4. I'm going to end up with a 3. 2 times 3 is going to give me 6. I'm going to get -19. And this one also is not going to work. Okay, moving on to -2. I'm going to have 2, -1, -25, -12. This is practice with synthetic division, so please practice. 2 times 2 is going to give me -4. I'm going to get -5. I'm going to get +10, -15. This one's also not going to work. I'm going to go to 3, 2, -1, -25, -12. Bring that 2 down. I'm going to get 6. I'm going to get 5. Once I add 15, -10, this one's also not going to work. So going ahead to -3, I'm going to have, again, 2, -1, -25, -12. Synthetic division, bring that 2 down. 3 times 2 is a -6. I'm going to get -7. -7 times -3 is going to give me +21. -4. -4 times 3 is going to give me a -4 times -3 is a +12. So this one works. So -3 is a 0 value that I have. So I'm going to go ahead and write x on the line equals -3. Keep in mind, I'm going to have 3 answers. How do I know I'm going to have 3 answers? Because of that degree. That highest degree is 3. I have to have 3 answers. So now that I know that -3 works, I'm going to go ahead and I have to try and factor this. I'm going to have 2x squared minus 7x minus 4 equals 0. Can I factor this? Let's check. 2 times -4 is going to give me -8. What multiplies to give me -8 and adds to give me -7? Good, -8 and a +1. So I'm going to have x minus 8 and x plus 1. Keep in mind I have this 2 here, so I have to slide and divide. This divides to 4, and this is going to slide. So I'm going to have x minus 4 and 2x plus 1. Don't forget to set all of those equal to 0. So I have x minus 4 equals 0. So 4 is one of my answers. And then 2x plus 1 equals 0. I'm going to subtract 1 from both sides. I'm going to get 2x equals -1, divide by 2. And I'm going to have x equals -1/2. So now I have a total of 3 answers. Okay.
Do we have to show, like, on the test or like,
4,
do we
negative
have to
1
show
half.
each example?
All right, now what are my zeros telling me? Those are my points on the graph. So I'm going to go ahead and graph them. Putting dots, I have -3, negative half, and a positive 4. Okay, now I can go ahead and use my end behavior. Okay, the first one is going down. Okay, it's going this way. And my end one is going to be going up. Okay, what is my multiplicity of each? Okay, what is it? Good, I have all multiplicity of 1. So what is that, odd or even?
Odd.
Odd, and is it going to bounce or cross?
Cross.
Good, it's going to cross. I will go ahead and put it in, we'll do pink. It's going to cross. Okay, that odd is telling me it's going to cross. So that means I'm just going to go ahead and cross this line, and cross this line. Okay, almost done. All I have to do now is find my y-intercept. And what would my y-intercept be?
Oh, wait.
Good, -12. So it's going to be not just -12, it's going to be 0, -12. And I'm going to go by 2s. This is going to be -2, -4, -6, -8, -10, -12. And I'm going to put a dot right there on -12. And then all I have to do is connect it. These two are going to connect. And then don't forget it has to pass through that -12 and connect at the other end. Doesn't have to be perfect, but it has to look something like that.